So recurrence relations can be useful in trying to model simple interest investments. And they can also be useful in terms of fixed rate depreciation and unit cost depreciation. Let's just review the terms. Simple interest is where an amount of interest is earned based upon the initial principal only. So if we increase a principal by a certain interest, every time we increase after another year, we add the same amount on every time. Regardless of how much money you have now, it's calculated only on the initial amount that you started with. So they're really useful in terms of recurrence relations to do those. Here's a question about a recurrence relation. Take a moment to read it, so pause it if you have to. Take a moment to read it and try and figure out what's being asked of you. So we've got some important things to focus on. So we've got an initial investment of $2,000, 3.8% per annum, and they've given us a recurrence relation here already. So they've actually figured out some stuff for us. The 2,000 in here represents the 2,000 that we started with. And the 76 is actually what the 3.8% per annum would be. So if we were to use our old-fashioned I equals PRT formula over 100, we'd have I is equal to 2,000 times 3.8 times 1, because we do it for 1 year, over 100, and that actually gives us that 76. So we're going to use the recurrence relation in this instance to find the value of the investment after 1, 2, and 3 years. So if we know V0 is 2,000 up here, then V1 has to be V0 plus 76 according to this recurrence relation here. So that's going to be 2,000 plus 76, 2,076. So we want to do all 3 years. So V2 is V1 plus 76, which is 2,076 plus another 76. And that gives us 2,152. And we go V3 is equal to V2 plus 76 is equal to 2,152 plus 76, which takes us to $2,228. Each of those is in dollars. So we'd have $2,076, $2,152, and $2,228. So the second question here asks us to use our calculator to determine how many years it will take for the value investment to be more than $3,000. So there's two ways to do that. The fast but sometimes clunky way is to open up your calculator and put in the initial, which is $2,000, and press enter, and it just stores it in the local answer. And then if you press Control minus, you get this ANS thing, and we're going to add in the $76. We go plus 76. Press enter, and that gives us 2,076. That's 1 year, and we press enter for 2 years. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to take 14 years to get to 3,064. There's another way to do that. So if you add a new page into your document, we add a graph. If you press menu, graph entry, sequence, it'll ask you to put a sequence into your graph here. Now it uses some strange language. Instead of Vn and Vn plus 1, it says U1n. So we have to think back to that n and n minus 1 relation. So we're going to call it U1 brackets n minus 1 plus 76. And we're going to start at $2,000. And we started with V0, so I need to change this 1 to a 0. And I probably don't need to go to 99 years, so we might scale that back to, say, 30 just for the sake of it, and press enter. Doesn't show you anything at the moment, but if you press menu, window fit. It shows you these series of dots which tell you all the values of the investment in those first 30 years. And an easy way to find those is to then press menu, table, split screen table. And on the right here, it gives you all the values of the years one by one. So we can just sort of scroll down this menu until we find what we want, which was 14 for 14 years. And if we really need to, we could keep going, keep looking. If the question said $4,000, go to 27 years, keep going after that, and it goes on and on and on and on, which is great. So very helpful. That was 14 years. Part C, write down a recurrence model if $1,500 was invested at 6% per annum. So we know that our recurrence relationship is going to be something like Vn plus V0 equals A, and Vn plus 1 equals Vn plus D. So we need to find this D and we need to find that A. So the A is going to be equal to $1,500. That's the principal investment. This D is going to be equal to the interest earned per year because it's simple interest, which for us we're going to use I equals PRT over 100. Okay, that will get us the amount of money that we need. So we're going to go I is equal to PRT over 100, 1,500 times 6 times 1 year. So we always do it for 1 year over 100. We do it for 1 year because we're just trying to find the general amount of interest earned per year, so we can keep adding on after that. Bit of quick maths tells us that 6 times 15 is 90. That should be $90 there. And our final result. So now that we have this $90 and this $1,500 for D and A, we can write down a recursion relationship, which will be V0 is equal to 1,500. Vn plus 1 is equal to Vn plus 90. Flat rate depreciation is a similar idea. It just works decreasing instead of increasing. So here's $2,500 on this computer, and it has annual depreciation of $400. Okay. So we're just going to do the same thing but go down. You can imagine the value of a computer going down over time. That's what we're going to be modeling with this recurrence relationship. So we're going to find the value of the computer after 1, 2, and 3 years. So we're using this recurrence relationship here. So we're going to say V1 is equal to V0 minus 400, because we're doing Vn plus 1 equals Vn minus 400. So we're going to go $2,500 minus $400, $2,100 for V1. V2 is equal to V1 minus 400, is equal to $2,100 minus $400, is equal to $1,700. V3 is equal to V2 minus 400, 1,700 minus 400 is equal to $1,300. You have to be really clear about what you're being asked to do. If you're asked to use the recurrence relation to find the value, you will need to show some kind of evidence that you're using it as opposed to just doing it in your head or using a different method, possibly with a calculator. So they expect to see that you do it on the page. Use your calculator to determine how many years it takes for the value of the computer to be less than $1,000. So we're going to put this into our calculator. So this time I feel like closing this table. So menu, table, remove table. And I'm going to go back to the first one that I had in my graph. And I'm just going to edit it. So instead of making a new one, so U1 n equals U1 n minus 1. And we're going to be doing minus 400. And we're starting at 2,500 and we're going 0 to 30. And we press menu, analyze, window zoom fit. This time it's going in that direction. Menu, table, split screen, 2100, 700, 1300, and we wanted to know when it went below 1000. So V4 is 900. So we would say, therefore, the computer takes 4 years to be worth less than $1,000. And you'd answer that full sentence on your exam or your SAC. Write down a recurrence relation model if the computer was purchased for $1,800 and depreciated at $350 per annum. So we're going to write a new recurrence relation. This time the amount was given to us, so that's helpful. So we say V0 is equal to how much it started with, 1,800, comma, Vn plus 1 is equal to Vn minus 350. Finally, the last kind of fixed rate depreciation. There's two kinds, flat rate and there's unit cost. Unit cost is how often something gets used. So this time we've got a printer that was purchased for $450 and depreciates by 5 cents for every page printed. Notice here the value is 0.05 because this is in dollars, so that also needs to be in dollars, which is $0.05 for 5 cents. Okay. N is the number of pages printed. We're going to use our calculator to find the value of the printer after 20 pages. Okay. So we go to the calculator and we're going to put this sequence into our graph. So here we go. Close the table again. Menu, table, remove, press tab, press up to get back to the last one. This time we're going minus 0.05 and we started at 450 and we want to go 20 pages into the future, so we'll leave that as 30. Press enter. Menu, zoom, fit. Okay, gives us that nice depreciation shape there, which is what we're looking for. Menu, screen table. And on the left, we've got how many pages? 1, 2, 3, 4, 5. So we just need to scroll down until we get to 20. $449. $449. Write down a recurrence relation model if the printer was purchased for $300 and depreciated 8 cents per page. So this time V0 is 300. Vn plus 1 is equal to Vn minus 8 cents, $0.08.